mentioned that I have an NEC Plasma monitor. This is a Plasma Sync 50XP10, and it's a 50-inch high-definition monitor. There is no tuner in this set at all, and what it does is it pulsates on and off, and eventually it will stay on. So the problem is going to be a power supply problem. I don't have the base for this set, so I've got to kind of work on it lying face down. I've already taken the back off the set. You know what it's going to be. It's going to be capacitors, and well, these ones here, they're pretty bloody obvious as to which ones they are. I'll show you. So this NEC is actually made by LG. It's got the famous modules on it. This is the Z sustain board, and on the other side of the board over here, on the other side of the panel, you've got your Y sustain and your Y buffers on the other side, and this great big control board here. And here's our power supply, and our problem is going to be on the power supply. We've got caps, the tops are bulging, it's pretty obvious which ones are gone. So again, here's the base of the set box. It was brought to me in a box. Here's our buffer chips here, and our Y sustain board. The set, when it does start up, works. So we know there's no problem on any of the sustain boards. Our problem is going to be these capacitors here on the power supply board. Yep. Dead giveaway. Those caps are bad. So that's probably all that's wrong with this set. So I'm going to pull this thing apart here, and we'll start changing out some of these caps and see if we can get this thing going. So even some of these other little ones down the side, these Sanwa capacitors, not very good quality. Looks like that one's bad too, but definitely we can see that these ones, the tops are bulging on that one, and that one, that one, that one, that one, that one. So looking down here, there's 3 more of them here. So we're going to change these caps, change that one, and these ones here. And that's all I'm going to do on this set initially, is just change those capacitors, because I seriously think that that's the only problem that this set's going to have. As I say, once it gets going, it works, and there's a good picture. It's just getting it to turn on. It'll sit there and click on and off for several minutes before it actually catches and stays running. And that's typical of capacitors that are going bad. So I'm going to pull the board out. I'm going to work on the board outside of the set, and then once I've got the board repaired, we'll test it out. One thing I'll point out is to remove these connectors. They do have little lock clips on them, so it's a good idea just to take a screwdriver and just pop the back open like that, just to release the catch, and then the plugs can come undone. Otherwise, if you don't do that, there's a chance that you'll actually separate the whole connector from the board, and that would be a bad thing. So keep that in mind. These plugs do have little locks on them. Same with the power connector down at the front. Can't see it here, but the power connector down here also has a little lock tab on it. So what we've got on this set, there's a total of 10 capacitors that need to be replaced. Actually 11 capacitors, I guess. 1, 2, 3, 4, 5, 6, another one here, 7, 8, 9, 10, 11. And out of those, there's 9. There are 3,300 microfarad, 10 volt, high temperature devices. This one actually is a commercial unit. The client actually needs to fix this because it's used as a VGA type monitor for demos, right? It's an office environment. They're not using it as a TV, but they're using it with a computer for display. So it's got the VGA port on the back here, which is something that you don't find on newer monitors, especially of this size. So client wants this one fixed. It's not a bad unit, it's an LG, and we're going to get this one going, and once I get the parts in, we'll get the parts replaced and get this one back up and running. Okay, now that I've got a couple bags of capacitors here, we're going to get down to the business of replacing All these ones at the tops are bulging on. We're going to change them all. Because this is a paying customer as opposed to the last LG Plasma that I worked on that had bad caps was mine, was one that was given to me. And on that one I needed 3300 microfarad capacitors. And what I did is I paralleled 1000 plus a 330 in parallel to make my 3300 microfarad capacity. Again, that was my own machine. This one here being for a client, they're getting the original replacements, but maybe a little better quality ones than that were in there. We'll start out with this 470 up here. And again, I'm just going to heat the lead and rock the part out. That's the quickest way to remove a capacitor. Of course, if you're watching, that 470 is C287. Polarity is marked here, the positive and the negatives with the two little marks on the board. The longer lead is positive. We just place this cap through the board and solder it back down. So I'm going to be doing these one at a time so that I don't get them mixed up. Like when I mean one at a time, I mean like one size at a time. I'll do the 470s and the 1000s, and then I'll go back and do all the 3300s. All like size. So I'll pull all the ones that are of a specific size out first, and then go and do the others. That's generally the way I recap a board. That way there's no mistaking sizes once you've got the board empty. So next comes the 1000. Again, just heat, melt the solder, and tilt the part out. This one's C275. Again, drop it in the board, bend the leads a bit, and solder it down. And now I'll start removing all of the 330s, or the 3300s. So I have 1, 2, 3, 4, 5. 5 of them here. 6, 7, 8, 9. I have 9 of them to replace. So I'll do these 5 that are all in this area first. Look at this side isn't even soldered down. Check this out. This one's broken right free from the board before I even work on it. You see, right here, it's not even soldered down. There's one out. The next one is this one beside it. There's 2 out. The next one below it here. So mounting the capacitors. So that's the first 5 replaced. We'll just bend our leads over to keep the components in place, so I can turn the board over and solder them in place. That's the first 5. I've got 4 more on the other side to change again. Over, I think what's on this side of the board. Yeah, these are the 4 down here. So that one, and that one have to be changed as well. And those, I think, are the only ones that are going to be bad on this. At least they're the only ones at the tops that are really bulging on it. I'll go over some of the others with an ESR meter and just make sure they're okay, but these are the most obvious ones that are bad. That should have it. That should have this board fixed up. I'll just get my ESR meter out and I'll go over a few of the other capacitors in here just to make sure there's no other ones that are going bad, and then we'll reinstall it in the set. Looks good. One. .03, .04. These are all good. So now it's time to remount the board back in the television. The board just sits in place and is anchored down by several screws. So we just carefully line up all the screws, all the holes in the board with the standoffs below for the respective screws. I've got all the screws here. We'll screw the board down in place, plug it back in, and then we'll test it. And it's going to be an interesting one because I don't have a stand for it, so I'm going to have to kind of prop it up on edge and kind of hold the set and try and run it at the same time. It's going to be interesting. One of the reasons the customer wanted to fix this set is because of the Vga input. And it's being used on a display. And as you can also see, it's got BNC type inputs. So you've got, this is a commercial display. So in addition to your composite and your component video, it has RGB and with horizontal and vertical drive. So little education in component video. Your composite video here has got your luminance, chroma, blanking, and sync all on one wire. S video has the luminance and the blanking sync on one wire and the chroma portion on a second wire. Component video has your luminance, which is the black and white portion of the signal, along with the sync, horizontal and vertical sync, on one wire, blue component on another wire, red component on a third wire. This is RGB with external drive. So you've got your red or component, your green or your Y, and your blue or your blue component, which is the same as these done on BNC connectors, but it adds 2 additional signals because the green doesn't have sync on it as it does over on your standard component inputs. Your horizontal and vertical drive signals are separate, so it takes 5 wires, which is exactly the same, incidentally, as you would get off of VGA. The 15-pin VGA connector has your red, your green, and your blue, which this can drive as red, green, or blue, but it can also drive as red component, blue component, and the Y signal, just as this, but it can drive it with a separate horizontal and vertical sync signal. Same signals on this connector here. And incidentally, you can put the same signals into a VGA input as you can through these. And there are cables that will actually break out VGA to 5 connectors and vice versa. And this can be run as either only using 3 with the sync on the green, just as in the regular component, or you can run it as 5 separate inputs. And then you've got DVI. DVI is digital video interface or digital visual interface, and it follows the video standard that HDMI uses minus the audio components. So there's no audio on DVI, so the audio is on a separate analog input, and there's no encryption. These controls here are these RS-232 connectors. These are for serial control, and that's so that if you had an institution, for example, you're using this for digital signage, such as say at an airport or whatever, you could control them all over a serial cable, and it would loop in from one to the next, and you could send a power command right to 50 monitors or switch them all to the same input. That's just for control. That's remote control. And basically the signals that pass through here would be the equivalent of the infrared signal. Again, this being a commercial display, that's what it was designed for. Once the board's fastened in, again, it's time to connect up the power connectors. These connectors are all keyed, so they basically only go into one place. It's pretty tough to mix them up when there's a unique number of pins per connector. So this one goes down here, plugs in there. We have a little 2-pin connector that plugs in down here. Another connector that plugs in over here. And our main power connector that plugs in over here. Okay, let's fire the TV up. And, well, that's a good sign. That part's working. Let's get some signal happening here. I know the panel's working because I can see some light on it here. I'm just waiting for there we go. It's starting to play. Obviously the size isn't right because I have to resize it for the size of the screen, but we have a picture. I'd have to go in and play with the size. The output from this media player right now is set for, I think it's set for 1024 by 768, and this panel is a higher resolution, therefore you only get a partial picture from this. I'd have to get in and adjust the size. I don't know where it is in the menu here. It's RGB, DVI, video 1, 2, S video, VGA. Should be able to, there we go. I just resized it. So now, as you can see, I've stretched the picture out to fit the panel. Therefore, we have another one that is fixed and ready to go back into service. Here we go. Looking good. Thanks for watching.